recording after this. Okay, yeah, let me share my screen. Okay, hope everyone is able to see my screen. I'm so excited to be here again with you all. Thank you again for joining the session. And today we will be sharing with you how to bring STEM to life with VEX IQ. It's one of my favorite topics. I wanted to talk about how to implement interdisciplinary, cross-curricular, and integrated STEM projects, in particular with robotics and with VEX IQ. So a few things before we start. If you have any questions, please do send your questions in the chat box, or you can save your questions and we will be addressing all of your questions in the Q&A session. And this session is centered around ways to be able to use robotics in your classroom and ways you can do to connect with other curricular resources. For example, like things you can do with robotics to teach math, to teach literacy, and how to use those project-based learning, all those exciting STEM projects. For the agenda today, first of all, I will give you a very brief introduction about VEX IQ, because I know some of you, have experience in IQ, but some others don't. So before I jump into the fun projects, I will give you a brief introduction about VEX IQ, and then we can explore why IQ is a great vehicle for integrated project-based learning. And then that's the key for today. I will share with you some ways to bring STEM to life with IQ. Especially, I will share several fun projects with you, which are look-alike contest, bumper card game, spin the wheel game, and automata activities with you. And the last part, I will be sharing with you some of the free teaching and learning resources to help you get started. In case for those who don't know about VEX, we are an educational robotics developer of hardware, software, and curriculum that is used in classrooms all around the world. And we are wholly owned by Innovation First International, founded in 1996, and now we are a leader in educational robotics. And our headquarters is the US, our engineering team, our education team, most of them are based in the US, and we do have local support here in APAC to support educators, teachers, students in the region. And I myself is based in Hong Kong. I support educators in APAC. So if you have any questions or if you want to know more about our teaching and learning resources and fun projects, you can feel free to reach out to me. I'm sure all of you got my email address because I sent out, the webinar information. So you should be able to get my email. We are also the world's largest competition, robotics competition hosts. There are, students from all around the world. Over 61 countries have participated in our competitions before. So we're really excited and, we're really proud for our achievement and help to improve STEM education in, all around the world. A little bit of introduction for VEX IQ. The VEX IQ we're sharing with you today that are the second generation, and this is a plastic construction system for students ages 10 to 14. Of course, the students, they have different abilities and their learning styles are different. So this is just the suggested age. And you can definitely, change that, adjust that a little bit according to different abilities of your students. And we call this as a plastic construction system because students, they will need to design, create, and build their robots first using the plastic parts and also, different kind of electronic parts, electronics and, all different parts to build their robot. And then they have to code their robot using either block-based coding or text programming. Text programming here, we mean we support Python and also C++ for our text programming. And we also offer educators with free teaching and learning resources. In terms of the weeks of lessons, we have different sets of lessons and pacing guides for educators. And there are up for like 30 weeks of lessons available for you. And in terms of the IQ education kit, you can see there are two boxes. One box is are like plastic parts, and the other box we have electronic parts and also different kind of motion components, and sensors and all those kind of things. And we also got the interactive parts poster online. If you have any questions about that, you will be able to find the resources online. And for schools, it's usually we would suggest classroom bundle. You can see there are a lot of STEM games elements there and fields, tiles provided to you, and you can do all kinds of activities with that. Okay, so that's a really quick introduction about VEX IQ, and I will also give you a very brief introduction of some of the projects for learning STEM with IQ, and then we can jump to some of the fun projects. We will be talking about like STEM, like how to use robotics to teach STEM. So I will give you several examples of each, and then you would be able to have a little bit understanding of STEM and also IQ. For example, this is one project to teach engineering with IQ. We know that the goal of this challenge, this is called stacked up challenge. The goal of this challenge is to use the controller to drive the robot and stack as many cubes as possible in a minute, or you can set different times, for example 5 minutes or 10 minutes. You can do this kind of project with students. And one of the key things in this challenge is the robot arm. You can see I've provided you with different kind of robot arms here. Just two examples. The first one is a swing arm, and the second one you can see it's a reverse arm. You can see this. We have different kind of double reverse arm. We have different kind of arms. For one of the key things I just talk about is the arm mechanism and what makes an effective arm design. What does it mean by an effective arm design? Students, they have to understand that, learn the mechanism of arm, and then they will need to apply their learning to stack as many cubes as they can in this challenge. And so in the process, students, I just talk about, they learn the design, building, and iterating on their arm design. That's definitely the engineer behind it. And they also gain a lot of like soft skills, for example, collaboration, as they need to work with team members to come up with different kind of arm designs. And besides for that, another important thing is grab. Because this is the clawbot and you have to grab those cubes. I've also just wanted to give you some examples of different kind of claw. It's about effective claw design. And effective claw is usually designed depending on the object that it is meant to transport. In this project, as you can see, they need to transport cube, but a lot of times, sometimes you need transport like ball or transport a triangle or different kind of thing. That's what you need to consider about an effective claw design. For example, object considerations for designing an effective claw includes the size of the object or the shape of the object. For example, I just talked about cube, ball, or triangle. That's the shape of the object. And you also need to consider the weight of the object and how high it is off the ground. That's also another thing you need to consider of. Besides for those kind of things, you will have to consider some additional things. For example, how many objects are you trying to move at the same time? And that depends, the claw, the width of the claw, and things like that. And what directions do you want to grab the object from? And how is your claw going to be attracted to your robot? So all those kind of considerations, you will need students to learn, during the process. And this is just use one example to introduce like learning science with IQ. In this activity, students, they will see how far an IQ motion bin can be pulled in 5 seconds, or, you can set this time as 1 minute or, 50 seconds or something like that. It's based on how and where a rope from the IQ kit was attached to the robot to create an unbalanced force. So students will learn about science during the whole process of this project. They will learn about force, how force affects the movement of the robot, and they will also need to apply this information to design and build a rope attachment for the robot to pull an IQ motion bin to the farthest. This is just one example about learning science with IQ. I will be sharing a lot of like fun projects, after this quick introduction of STEM. And this is pretty self-explanatory how you can learn math with IQ. This activity is called How Big Are Your Teeth? We want students, they to calculate the pitch of the gears and sprockets, and they can count, calculate the gear ratio. And this is definitely, about math. And during the process, they also need to understand, the gear, the output and input, and all those engineering things behind the math. And a very quick example about learning technology with IQ. Let's take a very quick look about this activity. As you can probably see, there is an optical sensor mounted at the top. Sorry, not at the top, it's at the front of this robotics, this robot IQ robot, and this is called treasure hunt activity. The robot, they will drive to 2 different IQ cubes and use the optical sensor to detect the color of each cube. We have the red cube here and also the green cube. If the cube is red, the robot will collect it and move it to the home zone, as you can see. If it's green, you can see now, the robot will not collect it. And students, they will learn how the optical sensor works during this process, you can see, and they will use the data from the sensor in the cube code to have the robot make decisions. So in this process, they will be learning about the computational thinking skills. They will be learning about like if, then, and repeat, because you can see the robot repeats the behavior. So they will need to understand the concept of loop and everything. And of course, they will also need to learn, how to design and create their robot. So this is one example of learning technology with IQ. And another one, we have attached the bumper sensor here. It can detect things or objects when the bumper runs into them. And this program will drive reverse, you can see, until the bumper switch comes into contact with an object. It will stop driving. And you can also, change this, for example, reverse, drive reverse. So this is one example about learning technology with IQ. And now I just wanted to introduce this distance sensor to you. This is a distance sensor has attached to the robot, and in this animation you can see the robot turns in the direction of the cube, drives towards it, and push it off the field. So you have to make sure that the robot itself does not fall off the edge of the field. This is called castle crasher activity. And in this lesson, you'll learn about the distance sensor and how it can be used on the robot to detect objects. You also learn how to use a, different kind of block, wait until block, and, to understand the sensor feedback. So this is a very quick example. What I wanted to introduce you is the VEX IQ, a brief introduction. Like I use different introduce like, optical sensor, distance sensor, bumper sensor, all those different sensors. Yeah. In VEX IQ, we have all those sensors, external sensors, and also for the VEX IQ brain, there is a built-in inertial sensor. You can see probably it's it's not that big here. I mean, the small words, but probably you can see it. You can test, the heading. You can see the heading and rotation, pitch, yaw, and also, measure the accurate turns for your robot. Okay. that's a very quick introduction for, IQ parts and everything. And now I will jump to this, like introduce you ways to bring STEM to life with VEX IQ. So I'll be introduce some of the fun projects with you. And just please feel free to ask any questions in the chat box. And I also see my colleague Andy is also there to help. If there are any questions, you can just leave it in the chat box. Okay, so before I talk about, fun projects, I wanted to just share a research with you about authenticity. A lot of research and studies have done exploring the concept of authenticity in education, which has been over, the last 30 years, a powerful metaphor for educational practice, particularly as a guiding principle for some technology, innovations, education, learning using technologies that support students' learning. The concept of authenticity has a variety of meanings. Although a dominant interpretation is still that authenticity refers to the alignment of the educational practice with activities in the real world. Based on what I share with you here is a research has done like 20 years ago. Even though it's 20 years ago, it's still, applied to, you can still apply those, research nowadays. And a lot of researchers reinforce those concepts. It's done, and there are four kinds of authentic learning. What does it mean? Like propose 4 kinds of authentic learning. First one is learning that is personally meaningful to students, because authentic learning can arouse students' interest and motivation and can foster their, creativity and everything. So the first one, learning that is personally meaningful to students. Meaningful, there are a lot of ways, meaningful, either students, they are motivated or, they can relate it to their own lives. That's the first meaning of authentic learning. And the second one, learning that is related to the real world outside of the classroom. That means, of course, authenticity. And students will be motivated, arouse their interests. If, it's not for the sake of learning, they can relate that to real world. And it's really easy for students to relate, and it's easy for them to understand as well. And the third kind of authentic learning is learning that supports thinking or conceptualization of a discipline in its natural application. That's the third, authenticity. We really want to foster, students, their learning and they can thinking. And really, we want to encourage students to be creative and critical thinkers. And also, what they have done, what we have learned, they have learned in the, for example, in the STEM subject, each subject of STEM, and then they will be able to apply their knowledge, conceptualize the knowledge they have learned in each discipline, and then apply it in real world projects. And the last one, learning where the means of assessment is a true reflection of the learning itself. We often talk about, assessments of learning, assessment for learning. So assessments, especially in robotics and coding, we don't want assessment just to be, summative assessment, paper-based assessment. Of course, that's not the most effective way to help students, improve their teaching, improve their learning. We want it to be, formative assessment. So students, in all kinds of projects, all kinds of fun projects, that's assessment. And we really want assessment to be authentic as well. So those are some of, just the research funding, and I wanted to share with you about authentic learning. And also we want to apply that into our, robotics teaching and learning as well. Okay, what can we do to build a cross-curricular project? And cross-curricular, there are a lot of cross-curricular projects, and I'm sure you have done a lot in your school, especially, nowadays we emphasize a lot on cross-curricular. So today what we'll be talking about is about STEM cross-curricular project. Of course, you can do a lot of, other, for example, literature with music or something. But today we will be focusing on cross-STEM curricular projects. How to build a cross-curricular project? What are some of the key considerations when you design a cross-curricular project? What is meant by an effective or motivating project? There are several ways, several considerations. I listed here just as examples. The first one, think about concepts or skills that your students struggle with. Those are a good starting point because there are different kind of themes you can do. We always need to find a start. So we can think about concept and skills your students are struggle with, or they have problems with. That's something you can consider. And second one, you can think about topics or themes that tap into your students' interest and motivation. That's usually the most effective way. Students, when they're motivated, when they have interest in something, they will devote themselves, and that's intrinsic motivation, and they will be really interested in that, especially for some students, they lack interest in robotics or coding. You can find something that they are interested in. And third one, you can think about how to adapt or extend an activity or project from your class or another grade level or teachers to your setting and your students. Because a lot of time, for example, we're talking about IQ today, probably in your school or in your centers, you have already used other VEX products like VEX 1, 2, 3. That's for kindergarten or primary 1 and 2 students, or you have used VEX Go. That is for primary school students, grade 4 or about that age. You can think about something they have already done before, and then they can relate, or other subject, other things they have learned in other science projects, science subjects, or in literature subject, and then you can adapt or extend an activity. And the last one, you can think about ways to connect robotics to events that are happening in your school community or the world. For example, like Olympics, you can do a project about, do a school event about robotics Olympics, and then you can do some kind of context and, activities and challenges using that theme. So that way you can relate students to their community or what, they have experienced around the world. Okay, so those are just some of the suggestions if you want to build a cross-curricular project. And then I would be sharing with you some particular projects or fun activities you can do with students using IQ. Okay, so the first one is this project. It's called Look Alike Contest. For this look alike contest, you can see there are a lot of, I just want to share with the rules first with you. The first one, the rules is share images. You can share images of common animals, or you can allow students to use their imaginations. For example, here I put an image of a turtle there. You can share this image with students, or you can share some images of, animals they have learned in their science lesson, they have learned in their biology lessons. And then you can allow students to do some free builds, or that you can use their, they have to use their imaginations. And you can challenge students to come up with a design using VEX IQ parts to recreate the animal. For example, let me show you here. This is what we have done. This is the turtle. We have shared the image of the turtle with students, and then we can ask students to create a turtle using IQ parts. Of course, if you have, Go in your classroom, you can use Go as well. You can see the legs of the turtle, and also there's a head of the turtle. You can use, the gear to create that, the wheels and gears, and also you can see it here. This is a turtle. And on the other side, you can see this is the giraffe. Of course, probably this is not the most, the giraffe, the look like, probably you think it doesn't look like giraffe, but it, created by one of our colleagues. And for students, a lot of times they can use their imagination to create the animals in this lookalike contest. For this activity, it allows students to, foster their creativity and imagination. And also there are a lot of cross-curricular content you can do. For example, you can relate that to English learning or language learning, literature learning. Like you can learn about, relate that to a superlative award idea, superlative. For example, you can, to have this context, and the students who have the most colorful design will win the award, will win the context. So you can use those superlative ideas, the most colorful design, or the largest VEX IQ animal. So students, they have to look around and locate the biggest, the largest IQ parts they can do, and then they can use those IQ parts to create and design and build the VEX IQ animal. Through this activity, it also helps students to be familiar with the IQ parts, especially, in the first several lessons, probably they don't know how to locate different parts. They don't know, how to snap different pieces together. This is really a good activity to motivate students and to foster their creativity, and use it also to help them get familiar with different IQ parts. And you can also do some like most moving parts without motors, or most moving parts with motors. There are a lot of things or extended activities you can do with this. This is the first activity. The second activity, second fun game I wanted to share with you is this one called IQ Bumper Cars game. This actually simulates what a real bumper car scenario allows students to play bumper cars, and they got some, when you play bumper cars, you got immediate shock when someone hit you. Let me play this video, this demo.
Now my controller is not working. Oh, now it's being dead. Now it's disabled. So you have a few options for what you can do with this. Again, if I was going to drive, run it.
So this one is actually, we have attached a bumper sensor to the front of this robot. And when the bumper sensor bumps into something, the controller gets disabled for several seconds. You can set the time, for example, 5 seconds. And then after 5 seconds, you can use the controller again. So it's enabled again. And that way you can simulate the bumper car, the real bumper car scenario. And you can see I've provided the sample coding here. And if you want to, simulate this, you can do that, with your students. There are different ways you can do with this project. Of course, you can do this as a whole group activity, and you can have a large game of a bumper car game, and you can have a lot of students, they, just simulation of the bumper car scenario in, entertainment park. You can have 10 groups doing the same thing together. Or you can do this, this can be played solo with a field filled with obstacles. You can set up your field and you can set up the field and put a lot of obstacles on it. So students, they can drive their car with the bumper sensor on it. So they can navigate this field, with a lot of obstacles, and without triggering the bumper, so without bumps into those obstacles. And the one who drives through the fields the quickest will win the game. So there are a lot of ways you can do with this. This is just a fun project to share with you. And through this project, the students, they will be learning about, computational thinking, because you will need to, use the VEX code IQ to code their robots. They will be learning about computational thinkings, about how to, code a bumper sensor, and everything about, you can use block coding, or you can use Python And they will also need to learn, how to drive their controller, how to navigate their controllers. So there are different things they will be learning about through this project and simulating a real-world bumper car. Okay, and when we talk about authenticity, we also talk about assessment. We want to, use a lot of formative assessments in our projects instead of use, summative assessment. What I wanted to introduce you today, we can use IQ parts to create a spinner. You can create a spinner. Of course, you can also use VEXIQ parts to do that. And you can use the spinner to distribute prizes, or you can ask a lot of different assessment questions, use the spinner. And you can also use it as a math activities, with probability. So there are different ways you can do with the spinner. Here I wanted to play a demo to you. This has done by my colleague, and how you can build a spinner using parts. Okay, using IQ parts.
The first thing I have here is I have an angle beam pointing to be my arrow of what is the winning color here, or what is the winning option. From here, I have a shaft going through the center that's held on by a shaft collar on this side. When I take the shaft collar off, the whole thing fell out, which makes sense because I'm holding it this direction. But I have my wheel here, which is just a piece of paper taped onto some cardstock, so it's a little bit heavier, a little bit stronger. Then I had a spacer on this side so that my paper wasn't holding up right against this plastic. So these very small VEXIQ spacers are really helpful to help with any sort of friction and reducing friction between the wall itself and the rest of the piece, or not the wall, excuse me, the spinner itself and the rest of the piece. So it helps to reduce that friction, make that a little simpler. On the other side, I had a different spacer, one that was a little bit thicker. I was just experimenting with the different spacer sizes. So this is the gray spacer. And then another shaft collar to hold it on the other side. So this really was the main crux of my mechanism, was just a shaft, spacers, and shaft collars. And this was held up with a series of beams, all connected together using pins, using a corner connector here on the back to create that 90-degree connection, and blue pins. So it was a really simple build. This is something that you could create in VEXIQ, something you could create in VEXIQ as well. But what I really want to show you is another option.
Okay, so this is a really, quick to build builds. This only takes around, 5 minutes to build. And you can do a lot of assessment activities and fun activities with this. Just wanted to share with you. And the last fun project I wanted to share with you is this automata. Why we want to use automata? Because probably you can see there is a linkage system. That's a linkage system. I will talk about that in the next slides. The link system there. And our students, they can explore simple machines, the mechanical principles. How does a linkage work? And they can also use, automata, this project. They can create the interactive artwork. And you can also use this kind of project, different kind of designs for storytelling. And, students, they are really excited about that. You can use that in Makerspace project, or, use that in open day, or a lot of even for performance, you can use this kind of project. And for example, you can see on the animation on the screen, this is a talking box. So we have the linkage systems attached at the back of the talking box, and then you can create different kind of artwork, and then you can, ask students to create their stories and do storytelling, use this talking box. So the key here for this, the automata project is linkage. So what are linkages? Of course, there are a lot of engineering principles behind that, but I just wanted to give you a very quick introduction. What are linkages? Linkages, you can see, are collections of parts joined together to change or help movements. We have the moving pivot here, and also fixed pivot here. And also, you can use different kind of beams, crank and pin to a slider. So there are different kind of ways you can create that. The linkage is really easy to do, but using, the linkage, you can do a lot of fun projects with students. And another one I wanted to share with you, you can see it here. This is a ladybug. We attached this linkage behind this ladybug, and we can control that like that. You can see in this animation, you can use the shaft and to create that, and you can see the movements of the ladybug. Of course, you can do different kinds of things like storytelling with students. And if we disassemble that, you can see the structure of this ladybug. It's really easy to make. It only, takes you 10 minutes to do whole things. You just need to attach a box with that and create some different kind of literature, artwork. And then you can see the linkage system here. For the gear, it's just to create attachment, but you can use different kind of, you can put beams there as well. It really depends on you. And the key thing here, you can use, the beams and also shaft and pins to create this linkage system. Okay, so this is the last fun project I wanted to share with you, how you can bring STEM to life and a lot of, fun activities you can do with students. And before we wrap up, another key thing I wanted to share with you, because we share with you a lot of fun projects, and a lot of times, teachers are really busy and you don't have time to design all those fun projects. It takes a lot of time to create all kinds of materials and teaching and learning content. So what I wanted to share with you is our free education resources. Everything is online. It's STEM, it's education.vex.com, and we provided educators with pacing guide, teachers' notes, lesson plans, very detailed step-by-step lesson plans, and also, student-facing materials, worksheets, and all our curriculum are mapped to the international standards. For example, like NGSS, ISTE standards, CSTA standards, and a lot of like international standards. What I wanted to share with you is, for IQ, we have like over 25 STEM lab units. STEM lab unit here, what we mean is like each unit is standalone and it's a project. We really emphasize a lot on project-based learning, where it's achieving task. It's not for the sake of learning itself, learning about coding or robotics itself. It's a fun project and cross-curricular integrated STEM project, and students, they can do a lot of fun activities, and each project is a challenge. It's a classroom competition. So it's really motivates students. We have, for each project, there are around 4 to 6 lessons per unit. And it's centered around different subject areas, sensors, coding, engineering, or math. So different projects. Besides for the projects, we've also got activity lessons. We have over 35 activity lessons. Okay, so instead of using PowerPoint to share with you, I wanted to go to the website to show that to you, and then you would be able to know how to navigate that. It's education.vex.com. I know some of you haven't got any experience in teaching robotics or coding, so don't worry about that. You just go into education.vex.com, and today we talk about IQ, and you just go into IQ. You would be able to find those resources there for IQ, different kind of resources, and this is the STEM lab resources I talked about. For example, this unit, this project is called Tug of War, and there are 6 lessons. It's, scaffolding step by step to help students in the end to be able to, learn the concept, the knowledge, and then they could do this tug of war competition. Okay, so if we go back, I also talked about activities lessons. There are over 35 activity lessons for IQ. If you click into this activity, you will be able to find those activity lessons. And all those activity lessons, you can see it's just 1 page. Activity is really easy for teachers to follow, and there are not a lot of things for you to read. You don't need to read a lot of things. We provided you with step-by-step instructions. And also, if you want to cater for learner diversities, where you want to, provide level up activities, we have that there as well. Level up activities. Okay. And other thing, let me go back. The other thing I wanted to share with you is this pacing guide. If you want to plan your whole year curriculum or your semester, I would suggest you start with this pacing guide. For IQ, we've provided you with different sets of pacing guide, 36 weeks, if you can see here, or 24 weeks. You can see we've listed out all the STEM lab unit and activities there, and description of that activity and what kind of build it involves. If it's free build, it means that we want students to use their creativity and imagination to build their robot, and whether it involves programming or not, or the key concepts there, is it mostly about engineering or arts, or friction science. Of course, most of the projects are interdisciplinary, or the cross-curricular a lot of times, but what we've put here, key concepts, that's the main concept we want students to understand. And 14 weeks, and we've also got 12 weeks, 9 weeks. I won't go into details. I just wanted to share this resource with you, and then you would be able to navigate yourself. Okay, so that's what I wanted to share with you for STEM Lab. Of course, there are a lot of other resources on STEM Lab as well. And let me go back to the materials. Oh, the last thing I wanted to share with you is our professional development, PD Plus, this resource. So you can see for PD Plus, that's the professional development for educators. And if we go to the dashboard, you would be able to find, different resources we provided you with. We've provided you with a blog, and you can ask a lot of questions. If you click into communities, you can share your ideas and lesson plans, or even ask a lot of questions to communicate with educators around the world, general discussions about IQ or, 1, 2, 3. So you can communicate with other educators there on the community. And what else you can do? We've also provided free certification course for educators. So if you go to training courses, you would be able to find, all the training courses. You can filter by platform. So we talked about IQ today. You would see we have 3 certification courses about VEX IQ. So after you have, go through all those certification courses, you will walk away with a certificate. Of course, you have to achieve, over 70 answers correct. Yeah. And the most useful, one of the most useful thing, at least for myself, is the video library. We have created a lot of videos sharing with educators. It's about different products and also pedagogy and a lot of concepts, students or teachers who care a lot nowadays. For example, teaching AI in K-12. AI is a huge topic nowadays. And if you don't know what does it mean by AI, you can learn that through our videos and, learning about center, live session coding with Python. So we've provided you with a lot of videos there to help you understand not only the technical aspects of the robotics and coding, but also the pedagogy and then, the teaching and learning trends nowadays. We've also got other sessions, for example, live sessions. Of course, it's like US time, so probably not applicable for APAC here, but we will upload all the videos to our PD Plus website. And another one is one-on-one session. You can schedule one-on-one session with our education team and VEX experts who have designed all those curriculum for you. So you can schedule sessions there. You can talk directly with our US education team. That's really something useful for you. And if you have any, questions about how to teach with robotics, you can, sign up for this one-on-one session. And the last one is conference. So every year we host the educator conference. Usually it happened during our world championships every year in the US, and you got the chance to meet with educators around the world, and you can, talk to them and communicate with experts around the world, listen to the keynote speech, and you can, understand more about the concepts and pedagogy about robotics. Okay, that's the key things we wanted to share with you today. Let me see, is there any questions? Yeah, Omar asked, are the certifications free? Yes, you will need to register an account. I just signed in for the PD Plus, but yes, educator certifications are free on our PD Plus website. You have to register an account, and then you can, access all the certifications for free. Yeah. And I shared with you a lot of resources. Of course, we have other platforms available. We emphasize a lot on, scaffolding and provide students a path from kindergarten all the way to career level. What we have shared with you today is IQ for students ages 11 plus. And in 2 weeks' time, we will be sharing with you about VEXIQ VR. That's the virtual robotics platform. And you can code on the virtual robotics platform and don't need to use, physical robots. Yeah, that's what I want to share with you today. And if you have any questions, please feel free to unmute yourself for any questions or comments, or you can feel free to email us. I will be sharing the PowerPoint, the slides with you after today's session, and we will also be uploading the video, the recording to our APAC YouTube channel. Oh, I got another question. Is the PD Plus free or paid feature? PD Plus is a paid platform, but for the certification course, there are for free. If you want to start with, free certification course, you can do that just by registering in a free account. But if you want to access other resources, for example, like attend the educator conference every year in the US, or if you want to access to all the videos about pedagogy or, tactical things about that, then you will need to get a paid account for that. Thank you for that question. And any other questions? Okay, if no questions, or if you want us, if you think about any questions in later stage, please feel free to email me or our the APAC email account. Yeah. Thank you very much again for everyone's time today. Hope to see you soon in 2 weeks. Thank you very much. Thank you. Bye, everyone.
Bye bye, Kelsey. Thank you.
Bye. Thank you.
Yeah, bye.
Bye.